Hi there. Today we are going to talk about solving systems of equations using a process called elimination. And so we use elimination typically when both equations are in standard form. And as a reminder, standard form is ax plus by equals c. And so I'm just going to go through, here's a system of equations. I'm just going to go through solving this system using elimination, and you'll kind of see how it works, okay? But before we start, just as a reminder, a system of equations is just two equations that have the same variables. So you can see here, like in this top equation, I have one equation, two equations, and both of them have an x and a y. So they're a system of equations, right? And when we solve a system of equations, we're really looking for, when I graph these lines, where would they intersect? What's the point of intersection? So a solution to a system of equations is always going to be a point, and it's the point where the two lines would intersect at. All right, let's jump right in. So like I said, I'm just going to use elimination. And here's the process. Basically, you're going to take your two equations that are in standard form, ax plus by equals c, and you're literally going to add the two equations together. When I add the two equations together, my like terms are lined up. So I can add 3x plus 9x and get 12x, right? And then I'm going to add negative 5y plus 5y. Well, negative 5 plus 5 is 0y, right? And 0 times y, or 0 times anything, is just 0. So I don't need that. It kind of like cancels out. These two variables, these two terms, I should say, cancel out, or in other words, they're eliminated. So that's why this process is called elimination. So I'll write the plus 0 just so we kind of remember. But let me keep going. So now I have equals, and now I need to add 4 plus 8, which is 12. So all I did so far was literally add the like terms. Okay, now let me solve what's left over for x. So 12x plus 0, I don't need that plus 0. So I just have 12x equals 12. And I can pretty easily solve this and get x equals 1. But remember, with elimination or with any method, when I solve a system, I'm looking for the point where the two lines intersect. And they intersect at a point, x comma y. Well, now I have the x is 1, but now I need the y value. So I can take this x equals 1, and I can pick either the first equation or the second equation. Either one, doesn't matter. And I'm going to plug that in to solve for y. I'll just pick the top one. So 3x minus 5y equals 4. I just rewrote that top equation. And now I'm going to take this 1 and plug it in for x. So instead of x, it's 3 times 1, because whenever I plug in, I should use parentheses, minus 5y equals 4. So now that I've plugged in 1, I am going to solve for y. 3 times 1 is 3. 3 minus 5y equals 4. Now solving for y, I subtract 3. I have negative 5y is equal to 4 minus 3, which is 1. Now to solve for y, I have to divide by negative 5. So I get y is equal to 1 over negative 5, or negative 1/5. And now I know that these two lines intersect at that point, the point 1 comma negative 1/5. So that's elimination. You just went through an entire problem solving a system of equations with elimination. Elimination, when we eliminate something, we get rid of it, right? When we added these two equations together, these y's canceled out. So here's your steps for solving a system of equations by elimination. You're going to pick one variable to eliminate. And why, let's go back and think for a second. Why did these y's, let me erase this so you can see it, but why did these y's cancel out or get eliminated? They were eliminated because the coefficient of the y terms were opposite. -5 plus 5 is 0. So something's going to be eliminated when I add it together with its opposite. So when we say pick in this first step here, when we say pick one variable to eliminate, we mean the coefficients must be opposites, like 5 and -5, or 10 and -10. In order to cancel out, I have to add a number to its opposite. And so this little note here, you may have to multiply each equation to get the variable terms to cancel. We're going to come back to that in a little bit. We won't worry about that right now. We'll come back to that. But then we're going to add the two equations together and eliminate the variable. We're going to solve our new equation for the remaining variable, plug back in to either of the original equations to solve for the other variable, and we can also check our solution by plugging in x and y to both equations. Remember, we check our solution by plugging x and y into both equations and then saying, oh, it makes both true. And just some reminders, your answer is always going to be a point x, y, and that point is where the two lines would intersect at. All right. Let's jump in and try some example problems. So keeping in mind, both equations have to be in standard form. These are both in standard form, ax plus by equals c. And so if I look at these, remember, our goal is going to be to add the two equations together. If I add these two equations together, the x's, the coefficients of the x's, that's a -1 and that's a +1. They are opposites. So when I add them together, they're going to cancel out, right? All right, let's do it. So we're going to literally add the two equations together. So y plus y. So that's like 1y plus 1y is 2y, right? -x plus x. Well, -x plus x is 0. It cancels out. I don't need it. And now I have my equal sign. I need my equal sign. And let me add -3 plus -3. -3 plus -3 is -6. So that's the process of elimination. The rest should hopefully be easy. Now we only have one variable. Let's solve this for y. We divide both sides by 2, so y is equal to -3. But remember, I'm looking for the point of intersection. I need an x and a y. Let me erase this so we can see the original problem. But I can plug this y equals -3 into either the top or the bottom equation. I'll just plug it in here. So -3 for y minus x equals -3, right? So solving for x, I'm going to add 3 to both sides. -3 plus 3 cancels. So I have -x equals, and now -3 plus 3 is 0. And that's okay, don't be afraid of zeros. X isn't quite by itself. I still have to divide by -1. But 0 divided by -1 is still 0. Now my solution is the point 0, -3. This is the point where those two lines would intersect at, if I were to graph them. Okay, so here's another one. Think about which variable is going to cancel when I add them together. Which variable has coefficients that are opposites? Hopefully you can look at that and say, well, the coefficients of the y's are -1 and 1, so they're going to cancel. So let's add these two equations together. The x terms, this is a 1, so I have 1 minus 2, -1x. -y plus y, like we said, is 0. That cancels. Equals, and then -2 plus 7 is 5. Now solve for x. Divide by both sides by -1. So I have x is equal to -5. So good, I have x, but remember I need x and y because I need the point where these two lines intersect at. So I can plug this into the top equation or the bottom equation. And I've been plugging in a lot to the top. I'm just going to plug into the bottom just for the fun of it. So negative 2x, and x is negative 5, plus y equals 7. Negative 2 plus 5 is positive 10. And then to solve for y, I'm going to subtract 10 from both sides. So I get y is equal to negative 3. Now I have my x and I have my y. If I put them together, I know the point where these two lines are going to intersect at. That's the solution, the point negative 5 comma negative 3. Okay, so at this point, I would pause the video and try these two problems here. When you come back, when you unpause, I will review them with you. But as you go through, I want you to think about, if I add these together, what's going to cancel? So pause it now, try these. Okay, welcome back. Hopefully you tried these. And I'm going to quickly kind of go through these. When I look at number 3, if I add the two equations together, I can see that the x terms are going to cancel because 4x and negative 4x are opposites. So when I add them together, I get 0. And then when I add the y's, I have negative 5 plus 1. And so negative 5 plus 1y is negative 4y. And then when I add negative 28 plus negative 4, I get negative 32. So now I'm solving for y. I'm going to divide both sides by negative 4, and I get y is equal to positive 8, because a negative over a negative is a positive. And then once I have y, remember I can pick either equation and plug it in and solve for x. So I'll erase this so we can see a little bit better. But I'll just do the bottom one. It doesn't matter which one. I'll do the bottom one. Negative 4x plus 8 equals negative 4. So to solve for x, I'm going to subtract 8 from both sides. This cancels. I have negative 4x equals negative 4 minus 8 is negative 12. And then to get x by itself, I divide both sides by negative 4. So x is equal to positive 3. So my solution, again, where these two lines would intersect, they would intersect at that point. Okay, jumping over to number 4. I hopefully can recognize that when I add these two equations, the x's are going to cancel. When I add the y's, I get negative 1y. And then when I add, so I have an equal sign, and then I add the coefficients, I get negative 11. So then when I solve for y, I divide both sides by negative 1. I get y is equal to positive 11. So now I have my y. Now I need to plug back in and get my x. I'm going to, again, just plug into the bottom equation. Doesn't matter. You can plug into the top one, and you'll still get the same answer. But x minus 3 times 11 equals negative 28. And then negative 3 times 11 is negative 33, right? And then to get x by itself, I have to add 33. And so negative 28 plus 33 is positive 5. So my solution here is 5, 11. That's the point where these two lines would intersect. Okay. So take a minute, check your work, make sure you did that okay and you don't have any questions. Because now we're going to kind of take it up a notch. Now if I look at number 5 here, are the x's going to cancel when I add them? No, they're not opposites. How about the y's? They're not opposites either. You may notice, oh, the negative 22 and the positive 22 cancel. But they don't have variables. That's not going to really help me. We need a variable to be eliminated or to cancel. So we're going to force that to happen. And if I go back a couple slides to my steps, remember I told you we're going to come back to this note here in step 1. So this is what we're going to do here. You may have to multiply each equation to get the variable terms to cancel. I'll show you what I mean by that. Ready? Let's go back to number 5. So if I wanted to force the x's to cancel, you notice the coefficients are +2 and +10. They don't cancel as is, but if I multiply this top equation by -5, -5 times 2 is -10, right? And then -10x plus 10x would cancel. So I can force that to happen by multiplying by -5, but here's the thing. I have to make sure I multiply the whole equation by -5, not just the x term. So let's do it, ready? So -5 times 2x is -10x. So I'm multiplying by -5, I'm writing it down here. -5 times +5y is -25y. And -5 times -22 is going to be a negative times a negative positive, and use your calculator if you want to, but you'll get +110. So all I did was multiply the top equation by -5. So now I'm going to kind of cross this off. I'm done with that. Now I'm basically going to use elimination on these two equations, the original second equation and my new equation in red. So I'm going to use elimination there. I'm going to add the two equations together. 10x plus -10x cancels. 3y minus 25y is -22y, right? And then 110 minus 22, or I'm sorry, 22 plus 110 is 132. So I have -22y equals 132. Now to solve for y, I'm going to divide both sides by -22. Use your calculator, and a positive over a negative is a negative, and I'm going to get -6 there. Now that I have y equals -6, the rest is just the same. I can go back to either one of the original equations, plug in. So watch, I'm going to erase all this. I'm going to just plug into the top equation. So if I have like 2x plus 5y, well, y is now -6, right? Because we found that y was -6. So I'm plugging in that -6 equals -22. Now let's solve for x. 5 times -6, right? Now I have to add 30 to both sides. 2x is equal to 8. Divide by both sides by 2, and you get x is equal to 4. So the solution to this system is the point 4, -6. In other words, if I were to graph the two original lines, they would intersect at the point 4, -6. Okay. Let's try another one. So again, if I look at number 6, the coefficients as is aren't going to cancel. The x's, if I add them together, don't cancel. The y's, if I add them together, don't cancel. So let's talk about what I would have to do if I wanted the x's to cancel. So if I wanted the x's to cancel, this coefficient is a -8. What I could do is I could multiply this whole equation by +8, because if this is a negative to begin with, I want this term to be a +8x, right? So I would multiply the whole equation by +8. That's one option. Now, I'm going to rewrite the system. So this is just the original system, right? The original two equations. Think about, what if I wanted the y's to cancel? If I decided I want the y's to cancel, the coefficient here is a +2x. So I would want this coefficient to be a -2 because they need to be opposites. Well, right now it's a 1, so I would multiply this whole equation by -2, the whole thing. So you can pick, do you want to eliminate the x's or do you want to eliminate the y's and then multiply accordingly? All right, so because I kind of started with the 8 over here, I'll erase that and I'll just go with this. So I'm going to multiply the bottom equation by positive 8. So I get 8 times x here is positive 8x. 8 times 2y, 16y. And I got to grab my calculator. 17 times 8. So 8 times negative 17 is negative 136. Right? Use your calculator if you need to. So that's this equation. I'm just going to rewrite this equation right on top of it to make it easy for me to use elimination. And now this is set up to use elimination. Let me add the two equations together. Negative 8 plus 8x cancels out. So y plus 16y is 17y. 0 minus 136, negative 136. And now to solve for y, I'm going to divide both sides by positive 17. And when you use your calculator, negative 136 divided by positive 17 is negative 8. And now, just like we did before, I'm going to pick either one of the original equations. I'll use the top one. So negative 8x plus y is negative 8, right, equals 0. To solve for x, I'm going to add 8 to both sides. I have negative 8x is equal to 0 plus 8 is 8. And then to get x by itself, I have to divide by negative 8, so x is equal to negative 1. So what's the solution? Where do these two lines intersect? They intersect at the point negative 1 comma negative 8. Okay. So again, pause the video, try these problems, see if you can think about, does anything get eliminated as is? Can I just add these two equations together and eliminate something? If not, what can I multiply by? And then when you unpause, we'll go over them. All right, welcome back. Hopefully you worked through these. When I look at number 7, I notice the x's aren't going to eliminate because 3x plus 4x is not 0. And negative 10y plus 40y is not 0. So the y's don't eliminate either. But I notice that this is a 40. How can I pretty easily get this to a 40? By multiplying by 4, right? But I also need to keep in mind, I need the signs to be different. Well, if I want the signs to be different, this term down here is a positive 40y, right? So I want this one to be a negative 40y. The 10 is already negative, so I actually want to multiply by a positive 4. So let me do it. 4 times 3x, 12x. 4 times negative 10y, negative 40y. And 4 times negative 25, negative 100. I'm going to cross this off so I remember not to use it, because now, like, I'm crossing this off because the red equation that I wrote here is kind of like my new equation. And I'm going to use elimination to solve, right? So 4x plus 12x is 16x. 40y minus 40y cancels. And 20 minus 100, negative 80, right? So to solve for x, I'm going to divide both sides by 16. Use your calculator. A negative over a positive is a negative 5. Now I have x, I need y. I can plug into either one of the original equations. I'll just use the second one right here. So 4 times x is negative 5 now, right? Plus 40y equals 20. So 4 times negative 5 is negative 20. And then when I solve for y, I need to add 20 to both sides. So I have 40y equals 40. And I know I'm running out of room here, but I'll rewrite it. So 40y equals 40, right? To solve for y, I can divide both sides by 40, and y is equal to 1. So my solution should have been negative 5 comma 1. That's the point where these two lines would intersect. Okay, let's look at number 8. Number 8, again, If I leave it as is, nothing's going to be eliminated. But if I look at the x's, I have 88 and 8. I can pretty easily multiply this 8 by 11 to get it to be an 88, right? And so that's what I'm going to do. So 11 times negative 8 is negative 88x. 11 times 3y, and 11 times negative 1. Now, just so my two equations are kind of like right on top of each other, I'm going to rewrite the top equation. So 88x minus 5y equals 39. So now I have two equations that I can add together, and the x's are going to cancel. 88x minus 88x cancels. Negative 5y plus 33 is positive 28y. And 39 minus 11 is 28 as well. Use your calculator for those if you want to. Solve for y. To solve for y, I'm going to divide both sides by 28, and I get 28 divided by 28 is 1. And again, I pick either equation, doesn't matter which one. I'm just going to pick the second one because it seems to have like smaller numbers. And I'm going to plug in. Y is 1. So 3 times 1 equals negative 1, right? And I'm solving for x. So negative 8x, 3 times 1 is 3. And then solve for x. I have to subtract 3 from both sides. Negative 8x equals negative 4. And then when I divide both sides by negative 8, I get x is equal to, a negative over a negative is a positive, and 4 divided by 8 doesn't go in even. So it can be reduced to positive 1/2. So my solution here is the point 1/2, comma 1. That's, again, where the two lines intersect. All right. We're going to take it up another notch. If I look at number 9, let's look. Nothing's going to be eliminated, but if I look at the x's, if I look at the x's, I can't multiply anything by 4 to get it to be 7. But I also can't multiply anything by 7 to get it to be 4. And the same thing with the y's. I can't multiply 2 by anything to get it to be 3, or 3 by anything to be 2. So you're going to have to multiply both equations. So you're going to have to think about the least common multiple. Let me just pick y. I'm just going to pick either x or y. If I want to eliminate y's, I can multiply a 2 and a 3 and get them each to a 6. So I have to multiply 2 times 3. If I multiply 2 times 3, this will be positive 6y, right? Well, now I want this second term to be negative 6y. It's a negative 3 to begin with, so I can multiply it by a positive 2 to get it to that. But here's the thing, I need to multiply every term by the 3 and then by the 2. So let's start with that. Ready? 3 times 4x, I'll do this over here. 3 times 4x is 12x plus 6y equals, and then 3 times 14, get out your calculator if you need to, is 42. Now I'm going to multiply the second equation by positive 2, right? So 2 times 7x is 14x. 2 times negative 3y is negative 6y. 2 times negative 8, negative 16. When I add these together, 12x plus 14x is 26x. 6y minus 6y cancels out. And then 42 minus 16 is 26. So solving for x, I divide both sides by 26. I get x is equal to 1. And then I can take that x equals 1 and pick either equation. I'll just pick the top one. So 4 times x, well, x is 1, plus 2y equals 14. 4 times 1 is 4. And then solving for y, I get 2y is equal to 10. Y is equal to 5. So my solution where these two lines intersect is the point 1, 5. So again, you're going to see this process is exactly the same. Just in the beginning, I did pick a variable to eliminate and multiply. Let's look at this. Again, I noticed that the y's have different signs. One's positive, one's negative already. So that could be easy, but I'm just going to go with the x's because I'm going to show you the x's, 4 and 6, the least common multiple of 4 and 6 is actually going to be 12. So I can get the 4 to be a 12 by multiplying by 3. I can get the 6 to be a 12 by multiplying by 2, but I need them to be different signs. So I need one to be positive. They're both already positive. I need one to be negative. So just pick either the 3 or the 2 and make it negative. I'm just going to pick the 3. So now I'm multiplying everything by negative 3. So 4 times negative 3 is negative 12x. 5y times negative 3, negative 15y. And then 15 times negative 3 is negative 45. And now I'm going to, so that's that top equation. Now I'm going to work on the second equation. I'm going to multiply everything by 2. 2 times 6x is 12x. 2 times negative 4y is negative 8y. And 2 times 11 is positive 22. From here, the rest should be easy. We've done this a bunch. These cancel. And then negative 15 minus 8 is going to give me negative 23y. And then negative 45 plus 22 is negative 23. Divide both sides by negative 23. Y is equal to positive 1. And then I'll just plug back into the bottom equation. And I'm going to solve for x. So 6x minus 4 equals 11. Add 4 to both sides. So I have 6x equals 15. Divide by 6, divide by 6. X is equal to, 15 over 6 doesn't go in evenly, but I can reduce it. If I divide each of these by 3, I can get 5 over 2. So my solution is 5 over 2, comma, 1. Okay, so again, pause the video and try these. I'm just going to give you answers to each of these. So, and you can kind of check your answers. So the answer to 11 is 2 comma negative 2. And the answer to number 12 is going to be 10 comma 8. And if you think about what you multiply by, if I wanted to eliminate the y's, I could multiply by positive 3 to eliminate the y's, and then positive 2, because the signs are already opposite. And then in number 12, if I wanted to, let's say, eliminate the y's, I could multiply by positive 7 and positive 5 to eliminate the y's. But if I wanted to multiply and eliminate the x's in number 12, if I wanted to eliminate x's, I would multiply by 3 and 2. Okay, so you have your solutions there that you can check. So take a minute, make sure that you've gone through these, check your answers. Thanks for watching and have a great day. I actually got your